Alright, in this section here of Calculus 1, Applications of Differentiation, we're going to be working some optimization problems. So finally we're going to be able to put some of this derivatives and all that to some kind of use. And of course we're going to start out with something really simple. Alright, so here's the problem. Let me find a color here to write on. We'll use that color there. Okay, we want to find two positive numbers. So we are, make sure we've got everything set up here. We're going to find, and that's really too light. It's still kind of light. I don't know what's going on here. Try this. Well, anyway, we're going to find two positive numbers. Two positive numbers, and we're going to let these two numbers just be x and y. Okay, so we're going to let the two numbers be x and y. Alright, we darkened it up a little bit. Anyway, so we're finding two positive numbers. We're going to call the two positive numbers x and y. And we're going to say that the product is 16. So the product of the two positive numbers is 16. So x times y is equal to 16. So this is their product. And then we're going to say that their sum, x plus y, we want that to be a minimum. And of course, we'll write that just MIN in a different color. Alright, so what I'm going to do here is I want to get this equation here in terms of one variable, either x or y. So this is known as our primary equation, and this is known as our secondary equation. And in a finite course, if we were doing linear programming, we might consider this to be the objective function and these to be like a constraint. So what we're going to want to do is get this in terms of one variable. So let's say, for example, let's solve for x in this problem. So y is equal to 16 over x, right? Just bring the x diagonally down. And then what we're going to want to do is get this guy all in terms of one variable, and that's going to be in terms of x. So we're going to take this 16 over x, and we're going to substitute it right on in, right, for that y right there, since y is equal to 16 over x. And so now what I'm going to do is I'm going to rewrite this as s is equal to x plus 16 over x. So there we go, we got it all in terms of one variable. Now what we're going to want to do is take the derivative of this, but the first thing I'm going to do is rewrite this. So this is s is equal to x plus 16 times, taking this to the numerator, becomes x to the negative 1. Alright, then we take the derivative. So I'm going to say s prime is equal to, the derivative of x is 1, take this negative 1, bring it out front, times it by the 16x, subtracting 1 from the exponent, and we get x raised to the negative 2. Now what we're going to want to do is just go ahead, we say, okay, look, the derivative is 0, right? That's where we can find possibly a min or a max. And then we're going to have, and I'm going to go ahead and just put the x squared down into the denominator. And then what we want to do here is we want to solve for x in this problem. So I'm going to go ahead and say, okay, 16 over x squared is equal to 1. 16 is equal to x squared, bringing this up diagonally. And then of course we want to square root both sides. And remember, this is plus or minus, but we're looking for two positive numbers. Alright, two positive numbers. So it looks like x is going to be equal to 4, positive 4. So that's one of our numbers. And then to find what the other number is, we just simply come up here